Welcome to The Explainer. Today, we are digging into one of the biggest, most mind-boggling miscalculations in the entire history of technology.
So it all starts with this number, a number that, when the internet was first dreamed up, seemed just astronomically, impossibly large.
You're looking at the grand total of unique addresses available under the internet's first main system, IPv4. I mean, come on, 4.3 billion, that sounds like it should last forever, right?
Well, yeah, we're out. The whole supply has been completely used up. It's all gone.
That is the big question, isn't it? How on earth did we burn through all of them? To really get it, we've got to go back to the very beginning and look at the brilliant but, let's say, not so clairvoyant inventors of the internet.
So when the internet officially fired up back in 1983, the world was a totally different place. And the planners, well, they made a couple of key assumptions based on the world they lived in.
First off, nobody, and I mean nobody, could have guessed just how insanely popular the internet would become. They thought they were building a small network for researchers. What we got was, well, modern global society.
And secondly, they just never imagined the wild variety of things that would one day need their own online address. It's not just our computers anymore, is it? It's everything. Our watches, our cars, heck, even our toilets are getting online.
Okay, so because of these two massive blind spots, the system they designed to organize all these addresses was, let's just say it was incredibly wasteful. It was practically a blueprint for running out.
And this system was called classful networking. This is really the heart of the problem. It took that huge 4.3 billion number and just rigidly chopped it up into 5 different sized buckets or classes.
So let's just zero in on the main 3 classes here. The really important detail is that default subnet mask. You don't have to be a networking guru to understand this part. It just means that the size of the network was predetermined and locked in. And as you're about to see, the sizes were, well, they were worlds apart.
And this just perfectly shows the problem, doesn't it? A single Class A network got a whopping 16 million addresses. Now compare that to your home network, that's a Class C, which gets about 254. The difference in scale is just staggering.
All right, so now that we know about this crazy class system, let's play detective. Let's look at the 2 big pieces of evidence that show exactly how we blew through millions and millions of these addresses.
First up, massive, and I mean massive overallocation. The group in charge of handing out addresses, IANA, was giving away these enormous Class A blocks to single companies like they were Halloween candy.
So you had companies like General Electric, IBM, AT&T. They each got a block of over 16 million addresses. That is so many more than any one company could ever hope to use. But once they were given out, poof, they were gone from the public pool for good.
Now, the second piece of evidence is, maybe even more frustrating. It's the huge chunks of addresses that were basically roped off and made unusable from day one.
Millions of addresses were just set aside for special uses, stuff like multicasting or experimental projects. But the most mind-blowing case of waste has to be the 127 network, an entire Class A block, just gone.
So you have to ask, right? Where did this huge block of addresses go? What could possibly be so important that it needed 16 million IPs all to itself?
Well, the whole thing was reserved for something called a loopback address. All it does, really, is let your computer send a message to itself just to make sure its own networking gear is working. It's a handy little test.
And look, having a network test is a great idea. The problem wasn't the function. It was the absolutely absurd number of addresses they reserved to do it.
You heard that right. More than 16 million unique addresses permanently locked away for a job that really only needs one, a single IP. It's a truly stunning example of waste.
So when you put it all together, giving away huge blocks to single companies and then reserving other giant blocks for tiny little jobs, that's how we did it. That's how we torched 4.3 billion addresses in record time. Ever since, we've had to get really creative, inventing all sorts of clever technologies that are basically just high-tech band-aids and workarounds to keep the internet growing, even though that original pool of addresses is completely dry.
Which, leaves us with a pretty fascinating final question. If the whole original system is broken and we are totally out of addresses, then how is it possible that your smart fridge and billions of other new devices are online right now? We'll get into the very clever fixes for that problem next time.